Hi guys, this is Manjunath here, and today we'll be doing a tutorial video on ETAPs. We'll be modeling a 23-story building and applying dead load and live loads and even the wind loads on that. And the profile of the building is different for all the different stories. So here's the picture. Okay, as you can see, there are 23 number of stories, and the profile is different for all different stories. So here are the core profiles. So till 8 story, the profile is like this, and till 14 story, the profile is like this. The same for 19 story and for 23 stories, 20 to 23 stories. Okay. So all has a dead load of 2 kN per meter square, and the live loads are changing according to their profiles. So these are few columns and beams which we are going to use the dimensions, and M40 grade of concrete is being used, and HYST 500 by 250 bars are used, and slab thickness of 150 mm and M40 grade concrete is used, and claddings are applied, whose load is being applied as a 0.2 kN per meter, and wind loads are considered as per the Bangalore parameters. Okay, so let's start the model. So all this in metric as Indian we have to take, and number of grids in x direction is 4, and y is 4, and the distance is 6 meters from one grid to another grid, and okay, so number of stories will be 23, and typical story height will be 3 meters. So we have to do a custom story data. Okay, so 1 to 8 it is the same. So 8th story we have to go here, and then we have to make it as a master story, and then do all these stories as 8th. So let's keep this video short, so I'm going a little fast, don't mind guys. So after that we have 9 to 14. The 14th story will be the master story. Okay, and we rest all will be kept as 14. This is this helps us to define the load parameters very easily. So yeah, and after that for 15 to 19, so 19, yeah, 19, 19, 19, yeah. So the rest all things are same, and go to OK. So till then, the Skyfi Labs is an online course. Okay, so they'll be providing a number of courses for all the branches like civil, electronics, mechanical, computer science, and so and so. They'll be providing all the different kinds of courses, and these courses are online, so you can take an online coaching and then pay a certain amount. So during this lockdown period, they have reduced the pricing list. Even the workshops will be conducted. So they have training centers all over India. So it's a good coaching center. Okay, so you can take help of this in your lockdown period. Yeah. So this is a model. Now all we need to do is define the material properties. Okay. First define M40 grade of a concrete, Indian concrete, Indian, and M40 has been defined, and then define those rebars. Okay, 500 and 250. Okay. After defining that, define the frame section properties. Okay. So the frame section properties will be concrete. See, here we have column 500 by 500, C 500 by 500. So these two will be 500 and 500, and this will be 140. And the rebars, we have to change the longitudinal bar size 500 and this. So we are defining column, so this should be column. The rest all same, and press on OK. And define one more property for beam. So this is beam of a dimension 500 by 300, 500 by 300, and M40 grade of concrete. This will be 500 depth and this is 300, and the rebars will be same as the above, and this will be beam. Okay, so the covering will be 25 mm on the top and bottom. Okay, and that's it. Okay, so we have to make a copy of this column, add a copy of the property. This will be an easy procedure for us. Column 550 by 550. 550 and rest all will be same, only change this, and you need not to change any other parameters, so all will be same. Add a copy of this again. So next column will be 600 by 600, column 600 by 600. Okay, so this will be 600 and this will be 600 as well. Okay. So we have defined the three columns, and now we got to define beams. Add a copy of the property. Beam of size 550 by 350, 550 by 350, and here 550 by 350. That's it. Add one more property, that is beam 600 by 400. So this will be 600 by 400. So the rest all will be same. Now what we need to do is we have to add a new property and go to auto list. Okay. So by doing so, column auto. Okay, so this will be concrete. So these have been added to the auto list. So column, and that's it. And add new property, auto list, beam auto. Go to concrete and then add these three beams to the list, and then click on OK. So by doing so, what we can do is we are seeing the computer or the software to take its own sections to design from these three beams and these three columns. So we are saying that software to take any economical sections. Okay, so all we need to do is go to similar stories. Okay, and then we are done with the drawing. Sorry, defining. Now we have to draw columns. Okay, so here you can go and then select your column, that is column auto. Okay, and then you're in the you have to go to the floor number 1 to 8, any floors. Okay, so to the outcome we have to draw like this. The same goes with the beam as well. draw beams. You go to this and then select beam R2 and then draw your beams over here, and after that go to slab and oh yeah, so we have to define slab as well. Sorry about that. Okay, so let's define a slab section of say 150 mm and grade of M40, and this will be 150, and that's it. Okay, so we have got here the property, and then we will draw this. So here you can see only till one floor to 8th floor the properties are same. Okay, now we gotta come to plan and change it somewhere around 10, that is 9 to the next floor, that is 14. 9 to 14, click on any floor. Okay, so yeah, that's it. Here we have a shortcut option. So the next profile is only this, right? So you have to draw it like this. Be careful while drawing this. There should not be any replicates. Okay, we have drawn with the columns and we have to go with the beams. Okay. Yeah. So we are done with that, and then we have to go with the slabs. The slab 150. Okay. So like this, and then yeah. My system is a little slow, so it's taking up a little time. So go to the plan and go somewhere near 17. Next similar stories, and then click on OK. Okay, and then the next profile is in the plus manner. So we draw columns. Yeah. So the next thing is beams. We draw beams. Going for this. Okay, and after that, we draw your slabs. Yeah. So after that, go to plan view, and then 23 floor. That's the top. Okay, so here the profile is like this. So quick draw columns and quick draw beams and quick draw slabs, and that's it. You're done with the modeling. Now all you need to do is apply dead load to all these particular stories on the shell, that is on the slab. So dead load on the slab will be say 2 kilonewton for all these shells. Okay, so assign shell loads uniform, the dead load, and 2 kilonewton. Okay, so all you have to do is select these shells. Be careful while selecting the shells and assign shell load in uniform 2 kilonewton and apply. There should be a similar stories, or else you can just select all stories over here. Okay, and close this. Select. We will be selecting all the stories over here, all the floors. Okay, and then assign the shell load uniform to Newton, apply. That's it. So here in the 3D model, you can see whether the loads have been applied or not. So go to design, select this window, go to design, concrete frame, sorry, display. Go to display, load assigns shell, and apply. So here you can see all the loads have been applied. Okay, click on OK to exit. Okay, so now we have to apply the live load on all these similar stories. So go to similar stories, and then okay, so this is story number 2. Assign shell load. Okay, so uniform, and we have to assign a load of 5 kilonewton. This will be a live load, and this is a 5 kilonewton, and we have to select all these shells carefully and apply. Okay, so that's it, and go to plan. Select floor somewhere around 11. Okay, so let this be over here. 1 2 3 4 5 6 7. Select those, apply live load, and apply. Oh, I'm sorry, let's delete these loads because we are not going to apply a 5 kilonewton load over here. Select these and then delete the loads. This 5 kilonewton will be deleted, and you have to apply 4.5. Okay, so 4.5, 4.5, and select these shells and apply. Okay, and next go to floor number somewhere around 18 or so. Okay, so select these floors and assign shell loads uniform. Okay, and we have a live load of 4 kilonewton, 4 live load, and then go to apply. Okay, so after that go to floor number 22, apply, select these two shells and apply a live load of 3.5 kilonewton, 3.5, and apply. So that's it, you're done with applying a live load. Okay, if you want to see whether the live load has been applied or not, go to this tab and then display load assignment shells. Okay, live load, apply. So here you can see. Okay, okay, so here you can see the live loads of 5 and 4.5 and 2.5 and 4 and then 2.5. Okay, yeah, so click on OK to exit. Okay, so all you need to do is draw the go to plan and then go to base, apply. Okay, sorry, we have to click on this and then go to base and apply. Let this be in a 3D view. Okay, so this base all select all the joints. Okay, and select all the joints and then go to assign joints restraints and do all this as a fixed because previously they were pin jointed. So let's do the foundation as a fixed joint. Yeah, that's it, and now we have to do is auto cladding. Okay, so, select all stories and define that is draw auto cladding using floors. So yeah, so it's taking a little time to draw the claddings. Here you can see that the claddings have been done. Okay, so what we have to do is we have to apply a load of cladding. So we'll assign a frame loads distributed of say 0.2. Yeah, this will be a dead load. So 0.2 on the periphery of the building. We go to similar stories from all story and select these peripheral beams carefully, because the claddings will be done on the outer face, not on the interior face. Yeah, so here you can see the loads have been applied, and go to plan view. Okay, and click on story number 11 and apply. Yeah, so here again you have to apply this load with this particular model, and then select all this outer frame, that's the beams, and then apply. And here you can see the loads have been applied, and here as well. Then go to plan view. Okay, sorry, it is here only. So click on somewhere around 20 or so. No, somewhere around 18. Okay, so now we got to uh, apply the load for this particular profile. Then apply. Okay, so the load is applied, and then go to plan, click on 22, apply. Okay, click on these outer frames, and then apply. Okay, so you are done with the application of the load on the of the claddings on the frames. Now what you need to do is define a wind load pattern. Okay, wind, and this will be a wind. Yeah. Okay, so select the Indian code and then add new load. Modify the lateral loads. Okay, you don't change anything. For Bangalore we have taken, so that is the wind pressure will be 33. So terrain category will be all this will be same. Okay, don't change anything. So let's go ahead and click on OK. Okay, so now we need to assign the. Okay, so after applying the cladding loads on these particular frames, now we need to define. Okay, so now we need to assign the wind load to the walls. So go to cell loads, wind pressure coefficient. Okay, so you have to go to the seismic analysis code book, that is IS 1893. Okay, and then go to the table, and then you'll get these coefficient values. Okay, so let me just go through the values. Just a moment. Okay, so I'm sorry. You have to go to the IS 875 part 3, which is a codebook for wind loads. So you have to go to page number 14, table number 4. They will be you'll be getting the h by 4 value. H is the height and w is the width of the building. So if you do that, you'll get certain values, and depending on that, you have to apply the CP value. Okay, so this is wind load, of course, and windward and leeward. Okay, uh, so we have to go to plan. No, we have to go to elevation view and then select A. Okay, so A is the windward side, so we have to select the plane A and then apply. Okay, so here you can see, yeah, so the elevation. Okay, and you have to select all these claddings. Go to all stories and select all these claddings. Yeah, so now we need to apply the coefficient values, that is 0.7, 0.7, and apply. Okay, so the load is being applied, and now we need to go to the plan elevation view. Okay, and click on B. Okay, so select all these, select all this, and again apply. Now again go to the C value. We will just change the value to minus 0.25. Okay, and then let it be leeward side, and then apply. Select these frames and then apply. You go to D. Sorry, select and apply, and go to D. Apply. Select all these, then apply. Okay, so let this be leeward side, and then go to minus 0.6 and click on 1. Apply. Select these frames and then apply, and then go to 2. Apply. Select these frames and then apply the load. Go to 3. Apply, and select these frames and apply the load. And go to 4. Apply, and go to select these claddings and then apply the load. So now you are done with the application of loads. Click on OK to exit. Now the wind load has been applied, and all you have to do is analyzing the model. So run analysis, we have to save it as tall structure, okay, and then analysis. Take some time. Okay, so here you can see the deflections and all the floors. Okay, so if you want to see this in a 3D elevation, then yeah, here you can see all the deflection values, that is Rx, Ry, Rz values, and all the details. Okay, so if you want to see any particular detail, then yeah, if you want to see anything, and then right click on that particular beam or any member, you get the details. Okay, so let's go to now. We are done with the analysis. Let's design concrete frame view revise reference. This we have to keep as is, and design concrete frame, start design or check. Now the software will check whether the frames that we have given are adequate or no. If not, then it will change to the next higher frame. So now it will give you all the deflection, all the reinforcement values, and moment, share, all those values. Okay, it's taking a little time. So here you can see now all the bending moment values are being displayed in this particular 3D diagram, or else even you can see it in the uh, plan section. Okay, so it's in the elevation. Okay, so okay, so if it's not visible, then go to display, then deform shapes, forces and stress. Okay, here you can see the bending moments, and if you want to see the shear force, go to shear to, and then you will be able to see the shear force. Axial force, if you want to see, you can see it here. So as you can see, axial force goes on increases as it goes to the bottom slowly. So bottom columns will be heavier, and as you go on the top, you can give lighter columns as well. So let's go to design check whether all the members are passed or not. Okay, so here you can see 715 columns have been checked. Do you want to select them? Yes. So there are certain columns selected. Okay, so you need to revise those columns, and then you have to redesign it. And that's it about this tutorial. So using this technique, you can just um, model your buildings, and yeah, that's it. Thank you.